Welcome back to Aurora Tech Channel. Today, I will test the new Core One L from Prusa. Unlike other Prusa machines, this model is currently only available as a fully assembled version, priced at $1,999. This is a CoreXY fully enclosed printer. The build volume is 300 by 300 by 330 millimeters, exactly double the volume of the Core One Plus. The required table space is about 19 inches by 22 inches, 48 by 56 centimeters, including room for the screen, and the vertical clearance needed is about 25 inches, 64 centimeters. The Core One L features an all-steel exoskeleton frame for maximum rigidity. It has an upgraded AC heated bed that can reach 120 degrees Celsius from room temperature in about 5 minutes. With 2 circulation fans underneath, it also works as a heated chamber that can maintain the internal temperature at 60 degrees Celsius, which is great for materials like ABS, ASA, PC, and nylon that require a stable, warm environment. When printing PLA, TPU, or PETG in a fully enclosed machine, you usually need to open the door and top cover. But with the Core One L dual exhaust fans and automatically vented design, you can just print all materials with the printer enclosed. The extruder is the same nextruder with a planetary gear system and 10:1 gearbox ratio as the Prusa XL, Core 1, and Mark IV's. The maximum nozzle temperature is 290 degrees Celsius. For bed leveling, it uses a load cell sensor inside the print head, which probes the bed directly with the nozzle. Z offset is set automatically. It doesn't have an auxiliary cooling fan, but it features the same 360-degree cooling system as the other new-gen Prusa machines. In terms of connectivity, it supports NFC to send your Wi-Fi settings to the machine or use the touchscreen to select and join your local Wi-Fi network, as well as Ethernet connection. If you have multiple printers, Prusa Connect lets you manage them easily through the web interface or mobile app. You can also print locally without the cloud or go completely offline using a USB drive. For multicolor printing, the Core One L is also compatible with the MMU3 that allows you to print with up to 5 colors, and it also supports the new Bondtech INDX tool changer, which can print up to 8 materials with ultra-fast tool swaps and near-zero waste. According to Prusa, this upgrade will also be available to order soon. Compared to the Core One Plus, this printer also includes a buddy camera and a built-in accelerometer for fine-tuning input shaping. Optional upgrades include a filtration system for $80, as well as a GPIO extension board for external device control. I would like to thank Prusa for sending us this machine to review, and I would also like to thank VOXELPLA for sponsoring today's video. VOXELPLA is a US-based filament manufacturer that tests its materials in a 250 machine print farm running 24/7 to ensure consistent reliability and quality. VOXELPLA Plus is a modified PLA designed for higher impact strength, supporting high-speed printing up to 500 millimeters per second, while maintaining a flow rate of up to 25 cubic millimeters per second at a standard printing temperature of 210 degrees Celsius. All of their filaments, including PLA Plus and PETG Plus, are made in the USA and optimized for high-speed printing at an affordable price of $16.99 per roll. For print farms and other bulk orders, they offer additional discounts. They also manufacture 3D printing accessories such as filters, anti-vibration feet, and upgrades for Bamboo Lab, Prusa, Creality, and Snapmaker printers. You will see more details about the VentoBox 2-stage filter, as well as how to use their cobalt-free silica gel drying beads to keep your filament dry in my upcoming videos. For the first 100 customers, you will receive 10% off orders over $100. Visit voxelpla.com. The machine came in a huge box. There were some accessories on top, and there was actually another box for the printer. There were handles so you could easily flip the box 90 degrees and slide the printer out. This is a pretty good design that allows a smaller person like me to unbox this large machine. The whole machine is in one piece, so there is nothing to assemble at all. It came with a spool of 1 kilogram PLA, a print surface, a buddy camera, a handbook, as well as some tools. There are 3 screws to remove from the bed so it can be unlocked, 2 at the front and 1 at the back. The screen was placed inside the machine. To remove the screen, I had a split second of thinking about cutting this string. Fortunately, I didn't, as this is the ground wire of the screen. Instead, just cutting these 2 zip ties is fine. As you can see, this is the wire I almost cut. If I had, it wouldn't have been the end of the world, but I would have had to reconnect it using a heat shrink connector. There are no screws required to mount the screen. Simply snap the steel bar into the frame and it will be secured. After putting the print surface in place, the printer is ready to use. After the machine is on, you will see the same setup wizard as the Mark IV's and the Core One. Select the language, then you have the option to use your phone app to send the Wi-Fi info to the printer. However, I found using the screen is still pretty easy. Just select your network. It only supports 2.4 GHz Wi-Fi. Enter the password, and it should connect in a few seconds. If you prefer to use the machine within your local network, you can skip Prusa Connect, which is their cloud service. But I have more than 10 Prusa machines, and I'm used to using Prusa Connect to manage them, so I will set it up as well. I will then use my Prusa app on my phone to scan the code and add this printer to my account. Select Wi-Fi connected printer, choose the model Core One L, scan the code on the screen, then give it a name and set the location. I have some machines in the garage and some in the office. Okay, I can see it at the bottom of the list. The printer screen will also show a success message, then it reminds you to remove the screws that lock the bed and other protective materials, which I already did. For the door sensor, I will disable it and confirm again to disable it. That's all we need to do. Since this printer was pre-assembled and well packaged, it seems Prusa is pretty confident with their shipping boxes, and I will just leave it without recalibration and start testing. Let's load some PLA to do a simple test to make sure everything is working. From the moment you insert the filament, it triggers the filament sensor, and the printer will start the loading process. You still need to push it a few feet to the extruder, then it will trigger another sensor and start loading. Select the filament type, and it will heat to 215 degrees for PLA, and it's done. I will then insert the USB drive and find a quick preloaded G-code for the first test. Let's try this keychain, which should take less than 15 minutes, including prep time. The first time you change filament, if it's PLA, TPU, or PETG, it will move the print head to open the vent on the top automatically. If you load ABS, it will do the opposite and close the vent. When using the satin sheet, it's not as forgiving as the textured or smooth PEI sheet, so the first layer seems slightly over-squeezed. We will do more tests to compare different print surfaces later. Let's do a sound test. The meter is about 3 feet away. When the doors open, the sound level stays around 50 decibels. When the door is closed, it drops a few decibels, but it doesn't seem to make a big difference. Including prep time, the print finishes in about 13 minutes. The top surface looks good, and the satin sheet bottom also looks beautiful. Before I start the next print, I will go to Prusa Connect to update the firmware. You can select the latest version from the menu and send the file to the printer. It's going to take a while. It would be faster if you downloaded the firmware from the Prusa website and used a USB drive to flash it, but I prefer to use Prusa Connect. That way, I can update all my printers across different locations while sitting in front of the computer. Once the file is uploaded, just click Flash. When you go to the printer screen, it will load the firmware and restart, just like using a USB drive. Now let's print a benchy using the same VOXELPLA Pro. This filament has its own profile in Prusa Slicer, so I will just use it. I will send it to Prusa Connect, since I only have one Core One L, otherwise it would show other available machines as well. If your printer is currently printing, you can add the job to the queue. In my case, I will just start it right away. It's going to clean the nozzle at the corner of the bed and do bed leveling on the print area only. Using the default 0.2mm layer height fast profile, it finishes in 42 minutes, including prep time. The result is pretty decent. The surface quality is all right, the cooling at the front is good, and the line width and extrusion on the top are also fine. Then I will run my benchmark prints. Since the print bed is 300 by 300 millimeters, I can print all four at once using object by object mode. As you can see, it finishes one object before moving to the next, so if one fails, it won't ruin the entire plate. However, since I will be using a different filament for the Robo Alpaka, I will print only 3 at a time. The total time for all 3 models is 5 hours 41 minutes. I manually timed each print. The Honeycomb box is 1 hour 56 minutes, a little faster than the average of 2 hours 15 minutes. The tolerance test is 1 hour 18 minutes, also slightly faster than the average of 1 hour 30 minutes. The number slider is similar, about 24 minutes faster than average. Let's take a closer look at each model. For the number slider, the top surface is very smooth and the text is clear. The bottom has good clearance, as you can clearly see gaps between the tiles. All tiles can move freely. For the Honeycomb box, all patterns are completed without breaks and there is almost no stringing. Let's compare it with other printers. All of these printers can handle this model very well, and the Core One L is definitely among the best. For the tolerance test, the square side clears down to the tightest 0.05 millimeters and stops at 0 clearance. The cylinder side also clears to 0.05 millimeters and stops at 0, which achieves perfect scores on both sides. Next, I will print the Robo Alpaka for the surface quality test. The print finishes in 4 hours 34 minutes, right in the middle of the average time among the latest CoreXY machines. The print quality is decent, but limited by the Marlin-style input shaper, it is not perfect. Let's take a look at all 4 angles and compare it with other machines. Compared with the Core One, both the time and surface quality are almost identical. Compared with the Prusa XL, the default print speed of the XL is slower, but the surface quality is better. Compared with the Chitu Max 4 I tested 2 weeks ago, the time is similar, but like some well-tuned clipper-based machines, the Max 4 has better surface quality. Compared with the Bamboo Lab H2C, the A2C is faster, and the surface quality is also slightly better. Compared with the Creality K2 Pro, the K2 Pro is faster, but I think the surface quality of the Core One L is slightly better. Next, I will try some different materials. Starting with PETG, I am going to print a 300mm tall trash can to max out the Z height. Once again, it performs leveling only on the printing area, but this is very close to the full working area. When printing the first layer, I noticed that the satin sheet did not produce a perfect result. A satin sheet is generally less forgiving than a textured PEI surface, especially at a 0.32mm layer height. However, after a few layers, it becomes fully covered. This 300mm tall trash can, with 4 walls and 5 bottom layers, finishes in 9 hours 11 minutes. The overall surface looks very good. Since this printer is heavy and rigid, the surface quality at the bottom is similar to the top, and it does not degrade significantly toward the upper portion. The inside of the trash can also looks great. However, the imperfect first layer is still visible at the bottom. To confirm the cause, I printed another first layer at 0.32mm using the same satin sheet. As expected, it showed similar imperfections. When placing them side by side, the imperfect areas are not exactly the same, but I believe this is due to the lower forgiveness of the satin sheet. I then used the textured PEI sheet to run the exact same G-code again. This time, the textured sheet delivered a perfect result. To further test this, I printed a standard 0.2mm PLA first layer on the satin sheet. As you can see, it is usable for most prints, but still shows some imperfect spots. Running the same 0.2mm PLA first layer on the textured sheet with identical G-code once again produced a perfect result. So, the issue is likely caused by the lower forgiveness of the satin sheet. It may only become noticeable on very large prints, but we will continue using the satin sheet to see how it performs on other regular prints. Next, I will print some regular 95 ATPU. I store this spool in a camera dry cabinet at around 25% humidity. While lower humidity is better for TPU, this condition is sufficient for most cases. The surface quality is mostly good, and the interior is clean. Next, I use the default ASA profile in the slicer to print a crate with Prusa ASA. The profile sets the chamber temperature to 55 degrees Celsius, and the print starts when the chamber reaches about 53 degrees Celsius, which takes around 17 minutes. I also tested increasing the chamber temperature to 60 degrees Celsius, and it maintained that temperature throughout the print. The ASA print turned out beautifully, with zero warping or layer cracking. Overhang performance is also decent with proper cooling, and the bottom adhered well using a glue stick. Then I moved on to my favorite engineering-grade filament, Prusa PC carbon fiber. Unlike nylon CF, I can store it in the dry cabinet and use it anytime. Before printing, I switched to a hardened steel nozzle. I started with a small print, a holster claw for my dad. This print took about 27 minutes and turned out very well. It fits his holster perfectly, although I do not think it will reduce printing on his shirt, since what he really needs is more exercise. I also printed a 125% scaled propeller launcher with a 3:1 gearbox to test whether the gears run smoothly. This print finished in 5 hours 39 minutes. The PC-CF surface looks excellent, and the gears function very well. Next, I printed additional accessories for my dad's new toy, including several speed loaders for his 8-round revolver. This serves as a good batch production test using engineering-grade filament. The batch finished in 2 hours 48 minutes. I also tested PETG and PLA for comparison. PC-CF feels slightly tight when the loaders are new, but it should be more durable than PETG or PLA over time. Finally, I used multiple materials to print a case for these speed loaders. I used PETG for the rugged box body. It appears that when printing models with a smaller footprint, the satin sheet can still produce a perfect first layer. The box body finished in 3 hours 44 minutes. Aside from minor PETG stringing, the result looks great, and the bottom surface is perfect. I used M3 screws to assemble the hinges and printed 2 small latches using PETG in a different color. Then I printed the seal using super flexible 40D TPU. The printer handled it without issues. Here's the final result. The box locks tightly, and with the 40D TPU seal, it should be fairly airtight. All the speed loaders fit perfectly inside, and I am very happy with how it turned out. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. The packaging design is thoughtful and makes removing the printer easy. There is no assembly required, and the setup wizard skips all calibration steps, yet it still works well without any recalibration and performs exactly as expected. This is the fastest printer from unboxing to first print so far. 2. The heated bed is a huge upgrade from the Core One. It uses a much higher quality thick aluminum bed, and when heating from room temperature to 120 degrees Celsius, it only takes about 5 minutes. As far as I remember, no other printer can heat up that fast. Since this is a powerful AC heated bed, Prusa uses 2 fans underneath the bed to circulate air, effectively turning the machine into a heated chamber. 3. It handles all materials well, from very soft TPU 40D to stiff polycarbonate carbon fiber. Even with materials that are prone to warping and cracking, like ASA, it prints everything effortlessly. In terms of dimensional accuracy, Prusa machines are always one of the best, if not the best. 4. This is a very rigid CoreXY machine. As a result, it prints faster than the Mark IV's. While it is not the fastest, with the new high-flow nozzle installed by default, it can now keep up with other latest generation clipper machines. 5. The vent on the top cover now opens automatically, so you don't have to worry about the internal temperature getting too high and clogging the nozzle when printing PLA or TPU. It also closes automatically for materials that require a stable ambient temperature. 6. Just like the Core One, this is Prusa's future-proof machine, and you can expect future upgrades from Prusa to be available on this model. In particular, many users are looking forward to the Bondtech INDX, which can print up to 8 materials with ultra-fast tool swaps and near-zero waste. Now for the cons. 1. A drawback of this printer's Marlin-based input shaper is that it runs entirely on one STM32 MCU, which limits processing power. As a result, it uses simpler, more conservative shaping, leading to less effective vibration compensation at high speeds. It is typically tuned for good enough across Prusa machines, but it may still fall short in surface quality under side-by-side comparison with the well-tuned clipper-style systems. I also tried recalibrating the input shaper using the built-in accelerometer, then reprinted the Robo Alpaka model. I could see some marginal improvements, but nothing too significant. 2. The satin sheet is the default option that comes with the printer. It is more versatile across different materials, but it can produce a less consistent first layer than the textured PEI sheet, as its less forgiving nature requires extremely precise Z offset and extrusion tuning for a perfect result. When printing at larger layer heights like 0.32 millimeters, any slight variation in flow becomes more noticeable, leading to uneven areas. In contrast, a textured PEI surface, like those used on most machines in the market, is more forgiving and can achieve a perfect first layer under the same conditions. 3. The filament compartment is not enclosed. The included spool holder can accommodate larger spools, but the extended spool length makes it difficult to add a simple cover to enclose the compartment like what I did on my Core One. However, Prusa has released a new USS dry box as an optional accessory, which costs an additional $35. 4. The vent on the top cover can now open automatically, but it will only open or close on the first print after a filament change. For example, if I print PLA and then manually close the vent, it will not reopen automatically until I change the filament again. Since that simple printhead movement only takes a few seconds, it would be better to add it to the starting G-code so it can be automated for every print. 5. I believe many users interested in the Core One platform are waiting for the Bondtech INDX, which seems to be the ultimate multi-material printing solution. However, production capacity is a concern. Unlike 5 to 10 years ago, when choices were limited and you either spent $200 on a basic Ender 3 type machine and did a lot of tinkering, or $5,000 on an Ultimaker S3, which I owned, in my opinion. Aside from having a dual extruder for support materials, it did not perform as well as a Prusa. As a result, users were once willing to wait weeks or even months for a Prusa because there were not many good alternatives, but the market is very different now. I believe that Prusa may need to address this, or it's unclear how many loyal users will still be willing to wait months for the new INDX system. In conclusion, the Core One L is not just a scaled-up version of the Core One. It features a significantly improved heated bed, and with 2 circulation fans, it effectively functions as a heated chamber with excellent results. With Prusa Connect and Prusa Slicer, you can manage your printers, monitor your prints, and update firmware across multiple networks and locations under a single Prusa account. I really like using the Core One L, and it performs even better overall than the Core One. It is not cheap, but the build quality, thoughtful design, and seamless workflow make 3D printing more efficient and hassle-free. I'm especially looking forward to testing the Bondtech INDX system, which can print up to 8 materials with fast tool swaps and near zero waste. Once I receive it from Prusa, I will test it and compare it with other setups, such as the Bambu Lab H2C and other tool changers to see how it performs. I will add the Prusa Core One L to my recommendation list as the most reliable, future-proof, mid-size CoreXY printer on my website auroratechchannel.com. I included a link to this machine in the video description. Don't forget to also check out my website auroratechchannel.com, which tracks prices for popular 3D printers, laser engravers, and CNC machines to help you find the best deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.